All right, good morning, ladies and gentlemen. Welcome back to our online section or our remote learning. Today, we're going to jump into triangles. So this sheet I have made available for us if you finish the project early. If not, I'm going to put this up. This is basically going to be our notes. A lot of this will be review, but just a couple things to remind us and bring us back into thinking about triangles, because that's going to be all about what this section is going to be on. In this unit, you'll be working with something called trigonometric ratios to solve problems. So a trigonometric ratio there's three of them that we're going to deal with. There's sine, there's cosine, and there's tangent. So we generally refer to these as sine, cos, and tan for short. And basically these talk about the relationships between the different sides of a right angle triangle. So here I have a right angle triangle and I've labeled the sides. So hyp stands for hypotenuse, adj stands for adjacent, and op stands for opposite. Now, a couple things. The labeling is somewhat particular because we're not always going to see triangles this way, but the key bit is this is our 90-degree right angle right here. It'll always have this little box. Key thing to note is if I go across from my right angle, I'm always going to encounter my hypotenuse. As a reminder, this is my longest side. So it's always going to be my longest side. Now the opposite and adjacent depend on which angle we're talking about. So in this case, I've got this, what I like to call a reference angle. And we often give it this Greek symbol. So it looks like an O with a line through it. To draw a little bit bigger, it looks kind of like that. And we pronounce it theta. And this is the angle from which we get our opposite and adjacent sides. So if we look at our reference angle, the angle opens up from here. So if I go across on the opposite side, similar to what I did with my right angle, I find my opposite and my adjacent touches theta. Like it comes up and it makes one side of my angle. In both cases, if my angle is down here, one side is going to touch my adjacent side, one side is going to touch my hypotenuse. If this was my angle, this side would become my adjacent, this side would become my opposite. I'm going to leave those out just for clarity, but we're always going to look at one specific angle. And we refer to them as op, adjacent, or adj, and hypotenuse, or hyp. Now the three ratios, you might remember them, but if not, that's okay. Sine of theta was equal to opposite over hypotenuse, cosine of theta was equal to adjacent over hypotenuse, and tan of theta was equal to opposite divided by adjacent. So a good way to remember this is it's always going to be a fraction, but we're going to have a letter, and then we have the first letter of each forming kind of this pattern. So we're going to go up and down, up and down, up and down. So you might have seen this written out at some point. So this is our sine equals opposite over hypotenuse. This is our cos is equal to adjacent over hypotenuse. And then tan is equal to opposite over adjacent. What I like to do to remember this, or how I remembered this, is what do you do when you stub your toe? You soak a toe, you put it in some water. Sorry. But anyways, that's the way that I remembered it from high school. You soak a toe. So we're going to use this to figure out which equation to use. They all look very similar, so we use this trick to kind of figure out which equation we need to bring to the table for each problem. So your calculator will give you the ratios if you know the size of the angles. If you know the value of the ratio, so if you know the sides, but you don't know the angle, you're going to use something called arcsine, arccos, and arctan, or inverse of all of them. So on your calculator, it'll have a little -1. So the ones that we're going to look for, I'll highlight them on your calculator. You'll be able to see generally above the 3 buttons in your calculator, they're going to be a little sine -1, cos -1, and tan -1. This is for finding the angle of the triangle. So the way you can remember this, if you're solving for a side, you can use sine, cos, or tan, depending on which one. And if you have to find the angle, you have to use inverse sine or inverse cos or inverse tan, depending on what you have. So to go through a couple of problems, one thing, this comes up at least once every year. Make sure your calculator is in degrees. It should have if this is your calculator, it might have a little letter D, or it might have DEG up at the top. So if all your buttons are here, that is what you're looking for. The reason being is that there's another way we can measure angles, and they call them radians. So what I see oftentimes is sometimes the calculator gets switched by accident, and it'll say either R or it'll say rad for radians. You do not want your calculator to be in this. There's different number of ways to switch them between. It depends on the brand of the calculator, but just take a look. Look for a little D or DEG on your screen to make sure you're in the right mode, because it'll give you a different answer. All right, an angle, so looking at an example, an angle of 27 degrees, so it gives me an angle, is next to a hypotenuse of 18 centimeters. What is the opposite side of this triangle? So to start, I'm going to just start by filling in angles, and it doesn't really matter which one I pick as 27, so I'm going to pick this one. It says next to a hypotenuse of 18 centimeters. Well, which one's the hypotenuse? It's this one over here, so I can put 18 centimeters. And then it says, what is the opposite side? So I'm going to go across from my angle and do opposite. Now I need to think about which one I'm solving for, so I'm going to look at my SOHCAHTOA and see which one has both the opposite and the hypotenuse. So I'm looking for O and H. So I see sine is opposite over hypotenuse. This is the one that I need. Cos is adjacent over hypotenuse. Nope. Tan is opposite over adjacent. Nope. So I'm working with what the question gives me and what the question is asking me. So I have sine of theta is equal to opposite over hypotenuse. And I'm going to put it as sine over 1. Reason being is that we have some moving around to do. So looking at this, plugging in some values, I have sine of 27 degrees over 1 is equal to, I don't know what opposite is, over 18. So my trick here is I'm going to multiply both sides by 18 to bring it up. So I'm cross multiplying this up. So I have 18 times the sine of 27 is equal to my opposite. And this gives me opposite is equal to 8.17 feet. Or I can put 8.2 feet. Reason being I'm putting it in feet. Or sorry, it should be centimeters. My bad. So I'm keeping the same unit that I started with. Okay, next up. An angle of 52 degrees is adjacent to the side of 10 centimeters. What is the length of the hypotenuse? So again, hypotenuse, it's asking for. So I know that's my hypotenuse. Angle of 52, I can pick this one as being 52. It's just my reference angle. This isn't an exact triangle. Notice how these two look exactly the same. So I'm just drawing a triangle for my sake. So if this is my angle, my adjacent side is going to be the side that's touching it, but not the hypotenuse. So now I have 10 centimeters. Well, now I have adjacent and hypotenuse, and I have an angle, so I'm going to use the ka part of SOHCAHTOA. So I have cos of theta is equal to adjacent over hypotenuse, and I like to write out every kind of step of the way just to remind myself. So I can again put this over 1. So I have cos of 52 over 1 is equal to adjacent is 10 and the hypotenuse I don't know. Now right here I need to figure out what the hypotenuse is equal to, but it's in the bottom, and not only that, it's part of a fraction. So I'm going to cross multiply here, but if I just cross multiply the hypotenuse up, I'm going to have hypotenuse times the cosine of 52 is equal to 10. I just want to know what hypotenuse is equal to. I don't want to know what the multiplication is. So I actually have to divide both sides by cos of 52. So I'm actually going to go both ways with this. And I basically, the trick is I swap the positions of the cos 52 and the hypotenuse. So I have hypotenuse is equal to 10 divided by cos of 52. With that, I can now plug this into my calculator. One thing to be careful of is try and save the steps. If you can, figure out what the cosine of 52 is and then do 10 divided by whatever the number you get is, either as a decimal, or you can do, if your calculator has the answer function, you can do 10 divided by your answer. If you try to punch this all into a calculator, sometimes it can get a little bit weird and not play nice. But plugging these in, you get an answer of 16.24, and again, I'm remembering which unit I had for my other side, so this is in centimeters. Okay, last one. An angle is opposite a side that is 9 inches and adjacent to a side that's 14 inches. What is the angle? So this one's tricky. So I'm going to pick this as my angle. It actually doesn't tell me what the angle is, so I can't put a number in. I'm just going to put theta. So then opposite and adjacent are here, and it gives me the value is 9 inches, and this one is 14 inches. So now I'm using TOA because I see that I have an opposite and adjacent. So I have tan of theta is equal to opposite over adjacent. So then I have tan of theta is equal to 9 over 14. Now I can figure out what 9 over 14 is, but I don't want to know what tan of theta is. Tan of theta is already something happening to it. So to undo it, I have to do inverse tan of both sides. So these cancel, and I end up with theta is equal to inverse tan of 9 divided by 14. So be careful with these ones. Try to figure out what your answer is first, and then plug into a calculator and go like tan minus 1 of 0 point something, close brackets, equals, and that'll give you your answer. So theta in this case is equal to 32.34. And then angles, I'm not going to put them in inches because this is I'm trying to solve this angle here. So my answer is going to be in degrees. So our units are important for this one. Make sure you're answering in centimeters if the question gives you centimeters. If you're solving for an angle, your answer is always going to be in degrees. All right, second page. You might remember the Pythagorean Theorem. This was our a squared plus b squared equals c squared. Or in this case, we can think of it as adjacent squared plus opposite squared equals hypotenuse squared. Or I tend to combine the two. I have a squared plus b squared equals hypotenuse squared. The key bit, our two short sides are going to be here, and our long side is going to be on its own. So it's the short side squared plus short side squared equals long side squared. So it doesn't matter which order I put them in, but here it gives me two triangles that I'm going to solve the missing side for. So I'm just going to call this side A is 17 feet. This side is 44 feet. I picked the sides like this because 17 was smaller than 44, and I can see that this side's longer, but I know that my C, or my hypotenuse, is going to be the longest side. So I'm going to set this up as A squared plus B squared equals C squared. So I have 17 squared plus 44 squared equals C squared. Now I need to make sure that I am squaring both values separately and then adding them up. So as a reminder, 17 squared means 17 times 17. So I'll just write that down once. So this gives me 289 plus 1,936 equals C squared. So then adding them up, I get 2,225 is equal to C squared. Now, one of the things you can check, I see a lot of people stop right here. If we think about it for a second, it doesn't make sense that one side is 17 feet, the other side is 14 feet, and then this side is 2,225 feet long. How would it fit? How would it be a straight line? It wouldn't work. So remember, we have solved not for C, but for C times C. So our last step is I have to square root both sides. So then this gives me on one side, I'll just switch the two sides. So C is equal to the square root of 2,225. So I get a final value of C is equal to 47.17. And then the unit was beat. Done. Number 2, it now tells me I don't know what A is. I'm going to switch them. I'm going to put A down here. I'm going to put B up here. So this is 7 millimeters. And then it gives me C is equal to 25 millimeters. And I don't know what A is. And you'll see why I switched the A and B. It doesn't really matter, but for this case, I'm doing it just for the sake of keeping the triangle nice. So now I have A squared plus B squared equals C squared. So A squared, I don't know what it is, I can't change it, plus 7 squared equals 25 squared. So I have A squared plus 49 equals 625. Well, this whole thing is equal to 625. I want to know what just A squared is equal to. So I need to subtract 49 from both sides. So I'm going to have 625 minus 49 is equal to A squared. So then A squared is equal to 576. Now, be careful. Again, this side should be shorter than my hypotenuse. So as a trick, if this side is too big, I probably have missed a step. So remember, this is giving me A squared. So A is equal to the square root of 576. And this gives me a value of A is equal to 24, and then the units are millimeters. So this is my answer. And really, those are the two big skills that we're going to be using. The one other thing you can add as a note for yourself is angles in a triangle add up to 180 degrees. So one of the things, say in a question up here, there was a part B, and I asked, what is the other angle? You could solve it again, or you could do 180 minus 90 minus 32.34 degrees, because this side is 90, we've solved this side as 32.34. Everything adds up to 180, so this will give me the missing angle. That's something I'll get into a little bit next time, but for now, this is all. There's going to be an assignment that's going to build on this, and I'm going to have some notes to go along with it. But as always, take care, stay safe, have a good one.